Hello and welcome to Math Lab. Today I will be going through the 2023 OCR Add Maths paper. Before every question you can pause it and try it out, or just keep watching to see the solution. This is part 1 of 2 going through questions 1 to 9. If at any point you don't understand a word or have a question, it will most likely be in the description below, or you can comment and I will try to reply as soon as possible. The first aspect of this paper is the formula sheet. However, all GCSE formulas must be memorised and they are often needed in many of the questions. To begin with, the first question is, find the independent of x in the expansion of x plus 2 over x to the power of 6. Term independent of x just means the term without x in it. We don't want to work out the entire expansion as the question is only worth 3 marks. So to expand the expression, we can use binomial expansion from the formula sheet. And if we look at it, it shows that every single term in the expansion is of the form NCR multiplied by a to the n minus r multiplied by b to the r, where a plus b to the n is what's being expanded. So if we apply this back to the question, we get 6CR multiplied by a, which is x, to the power of 6 minus r, times b, which is 2 over x. So we'll just quickly do that as x to the r. And we know that we don't want any x in the final term, so the exponents of x to the 6 minus r and x to the r must equal in order for them to cancel out. So 6 minus r must equal r, therefore r equals 3. Now, if we sub this back into the original formula, we can get the term, which will be 6c3 multiplied by x to the 6 minus 3 multiplied by 2 to the power of 3 over x to the 3. Now, x cubed divided by x cubed cancels out, so it's just 6c3 times 2 to the 3, which equals 160. So for question 2, Jack throws 4 ordinary 6-sided dice numbered 1 to 6. Find the probability that he throws at least 1 3. Now we could work out the number of ways he could get at least 1 3 and then put that to the power of 4 because he throws it 4 times. But that includes many aspects and we want to be as quick as possible in this exam. So a better way of doing this is to notice that an independent event. So if we know the number of ways that he doesn't get a 3, we can just subtract that from 1. So the probability of not getting a 3 on a roll is 5 over 6. And the probability he doesn't get that on any is 5 to the 6 to the power of 4. Now, this is the number of ways when he doesn't get a 3. So we can write it like that. But we want the number of ways he does. And since he can't both get a 3 and not get a 3, then the probability of a 3 at any point is 1 subtract 5 to the 6 to the 4, which using our calculators equals 0.518. Question 3. Use long division to find the quotient and the remainder when x cubed plus 3x squared plus 5x minus 3 is divided by x plus 1. The main difficulty in this question is knowing the term quotient. Quotient is just a result of division, whereas remainder is what can't be divided into a whole. So now let's just get to the long division. So x cubed plus 3x squared plus 5x minus 3 all divided by x plus 1. Now x cubed divided by x is x squared, and we'll subtract that. And then 1 times x squared is x squared. So we get 3x squared minus x squared, which is 2x squared. 2x squared divided by x is 2x, so we'll go there. And then 1 times 2x is 2x. So what's left is 5 subtract 2x, which is 3x. Now, 3x divided by x is 3, and we'll subtract 3x. And then 3 times 1 is 3. Now, negative 3 subtract 3 is negative 6. And negative 6 divided by x gives no whole result. We'll get a remainder. So this means that x squared plus 2x plus 3 is the quotient, and negative 6 is the remainder. As usual, we will start with part A. Simplify the following. 1 over x minus 2, subtract 2 over x plus 1. Now the quickest method is to find a common denominator, which we can do by multiplying the first term by the second term's denominator. We'll do 1 multiplied by x plus 1, take 2 brackets x minus 2, and now there'll be over the common divisor, x minus 2, x plus 1. Now, this expanding, subtract 2x plus 4 over x minus 2 brackets x plus 1, which equals negative x plus 5 over x minus 2 brackets x plus 1. Now for part B, we're going to follow a similar method. We are going to look for the common denominator, which we can do by multiplying. So 2 brackets 5 plus root 2 plus 1 brackets 5 minus root 2, all divided by 5 minus root 2 brackets 5 plus root 2, which, when fully simplified, equals 15 subtract root 2 over 23. Also, just a thing of note, if you wanted to know, these cancel because it will become negative 5 root 2 plus 5 root 2. Question 5. You are given that sin theta equals negative 0.6 for theta is less than or equal to 360 degrees or greater than or equal to 270 degrees. Find the value of theta. Firstly, let's see what theta is outside of the given range. Sin negative 1 negative 0.6 equals theta via rearranging, so theta equals negative 36.8. However, we want it within the range, so if we use the graph I drew here on the right, we can draw along where negative 36.8 is. And if we draw a line across, it will show us any values of theta which also give negative 0.6. Now, this point here is less than 270, whereas we want a point between 270 and 360, and this point satisfies that. And we can see it's closer to 360 than 270, and using common rules, we know that 360 plus minus 36.8 will give us the second theta. The theta we want equals 323.2. Part B asks us, using Pythagoras' theorem, determine the exact value of tan theta. Now we can't just use our calculators because it's asking us how to work it out and a specific way it wants the answer. Now the first thing to look at is what sin theta equals. Sin theta equals negative 0.6, but the sign of a function equals the opposite over the hypotenuse. So if we do a right angle triangle and we make this theta, then this is the adjacent, this is the opposite, and this is the hypotenuse. And in this circumstance, we can just make A equals 1 because the sign of any right angle triangle is always the same. Now, we're looking for tan theta, and tan theta equals the opposite over the adjacent. So we know we want to find somehow adjacent or the hypotenuse or the opposite in order to get tan theta. Now, if we look back at the triangle, using Pythagoras' theorem, a squared plus b squared equals c squared, the opposite squared plus 1 squared, which is the adjacent, equals the hypotenuse squared. Or if we divide everything by h squared, o squared over h squared plus 1 squared over h squared equals 1. So this is quite abstract what we're doing, but we will get to an answer eventually. Now, o squared over h squared equals sin squared theta, as we see here. And sin squared theta must equal negative 0.6 squared. So we can just write that there, negative 0.6 squared. Now, 1 squared over h squared is what we're trying to find out. So plus 1 over h squared equals 1. And rearranging gives us h squared equals 25 over 16 and h equals 5 over 4. Now we want to work out tan theta, and we know tan theta is equals sin theta over cos theta, and cos theta equals the adjacent over the hypotenuse. Now the adjacent equals 1, so 1 divided by 5 over 4 equals 4/5. So cos theta equals 4/5. And tan theta equals sin theta over cos theta. So we get negative 0.6 over 0.8, which gives us negative 3/4. Now part A of question 6 is asking, a car accelerates from rest in a straight line. At time t seconds, its velocity is given by the equation v equals 20 multiplied by 1 subtract 2 to the power of negative t over 2. Calculate the velocity of the car when t equals 4, 6 and 8. Now this is just a substitution, so I'll show the first one. So we want to do v equals 20, 1 minus 2 to the negative, and we're just subbing in t over 2. And then we can just solve that using our calculators, which gives 15. Now for 6, we get 17.5, and for 8, we get 18.75. Just by subbing 8 in as t and then 6 as t, as we did with 4. Part B is asking, hence calculate an estimate of the acceleration of the car at t equals 6 seconds. Give your answer correct to two significant figures. Using the Suva equation, A equals V, take Q over T. Now, 8 and 4, the midpoint of that is 6. So, if we use those two as the start velocity and end velocity, we'll get an estimate. So, A equals then the final velocity, which is 18.75, subtract the initial velocity, which is 15, over 8 take 4, which gives us 0.94 ms to the negative 2. Now, this could be improved by using smaller intervals around t equals 6, because if we imagine the speed, this probably isn't accurate, but if it was a graph and at the time 6, we would work out the acceleration using the gradient. Now, you'd work out the gradient looking at 2 points and then working it out there, and the closer and closer you get, the closer and closer you get to the tangent. Question 7. You are given that the equation 3 to the x minus 4x squared equals 0 has three roots alpha, beta and gamma, where alpha is less than 0 and gamma is greater than 3. By considering the value of 3x minus 4x squared when x equals 0 and x equals 1, show that beta lies between 0 and 1. So the first thing to do is to just sub in 0 and 1. So 3 to the 0 minus 4 bracket 0 squared equals 1. And 3 to the 1 minus 4 brackets 1 squared equals negative 1. So we can see here that there's a sign change from positive to negative, and sign change in your answer should be the key word. Now, this suggests that at some point between x equals 0 and x equals 1, the graph intercepts the x-axis, and because alpha is less than 0 and gamma is greater than 3, the only root can be beta. By considering appropriate values of x, determine the value of beta correct to 1 decimal place. Now, the method I would use is iteration. So we first want to find an equation for x. 3x minus 4x squared equals 0. Rearranging gives 3x equals 4x squared, and x equals the square root of 3x over 4. Now, to use iteration on our calculators, we can type in 0 and then equals, and then type the square root of 3 times over 4. Now, every time you get equals, you will get x1, then x2, then x3, and so on. And eventually, you will get a very precise answer. So, x0 obviously equals 0. Then x1, if we look at our calculators, is 0.5. x6 equals 0.76. And x7 equals 0.76. So now that we've repeated the second decimal place twice, we can just round x7 because it wants to 1 decimal place, as x equals approximately 0.8. Question 8. The triangle ABC is such that AB equals 10 centimeters and angle A equals 50 degrees. Given that BC equals 10 centimeters, determine the two possible values of angle C. Now, the first thing to do in questions like this is to draw a quick sketch. So, if this is our triangle ABC, this is 50 degrees, AB equals 12 centimeters, and BC equals 10 centimeters. Now, using the sine rule, sin C over 12 equals sin 50 over 10. So, sin C equals 12 sin 50 over 10, and C is the sin of -1 of all that, which is 66.82. Now, it says state the two possible values, 2, because if we draw the graph of sine, you'll notice that at 66, it goes across and meets another value. Now, this is 180, so we can do 180 subtract 66.82 to give the second possible value, which is 113.18. Question 8b. State two conditions for BC such that if either of them is satisfied, there will only be one value for angle C. So the first condition could be that if we look at the triangle and we draw it out, A, B, C, 12 centimeters, 50 degrees, the 10 centimeter of BC is no longer as it's part of A if B equals 90 degrees. This means that C must equal 40 degrees, as 180 minus 50 minus 90 can only equal 40 degrees. So AB is perpendicular to BC is our first condition. The second condition can then be that BC is longer than AB. So if we draw it out again, A, B, C, and 12, and if BC is larger than A, that means AB, that means C is an acute angle. And since the ambiguity in the sine rule, which gave us the two possible values of angle C in the first place, only ever gives an acute and obtuse, it means it can only be the acute. Therefore, there's only one solution. Question 9. The point A has coordinate 3, 7, and the point B has coordinate 7, 1. Find the equation of the perpendicular bisector of AB. So the first thing we want to do is find the equation of AB. So y take y1 equals m brackets x take x1. Y take 7 equals 1 take 7 over 7 take 3 brackets x take 3. Now, solving that, we get what equals -3 over 2x plus 11.5. Now, the perpendicular m of that is -3 over 2 times m equals 1. So, m equals 2/3. Now we know that the perpendicular bisector's gradient is 2/3. We need to work out the midpoint. So, we'll write m equals 2/3 over there. The midpoint, because it's the bisector of AB, is 3 plus 7 over 2 with 7 plus 1 over 2, which equals 5,4. Now, the equation of the perpendicular bisector we now know is y take y1, which is 4, equals 2/3 brackets x take 5. Now, Add Maths always wants 3 terms, so we have to rearrange this to get 3y equals 2x plus 2. Thank you for watching, and if you enjoyed the video, please like and subscribe. If you have any questions or suggestions for my next video, just leave them in the comments below and I'll answer them as soon as possible.